Hello, my name is Chisom, and I'm here to provide some insights on some of the research we've done on the response of gravity-based structures to multidirectional cyclic loading and why we should design our models for the environment we actually face and not just the one we assume. So offshore wind turbines are subject to a combination of wind and wave loads, and when we're designing them for operational loading that are assumed to be aligned, but the reality at sea is often different. For example, if we look at the wind and wave roses from 5 offshore wind farms at 5 locations globally, we see that these loads are often misaligned, and sometimes that misalignment can be up to 90 degrees. So if we want to design safer and longer-lasting gravity-based structures, an understanding of the performance under this complex loading is required, and that's the knowledge gap that we are trying to fill. To do this, we focused on centrifuge testing of small-scale models, as shown on the left, and we applied this loading configuration, which consists of a constant mean load applied perpendicular to a cyclic load. And this was carried out using the 3 actuator system developed at the University of Gustav Eiffel for modeling multidirectional loading configurations. We focused on the foundation level rotation, which is reflected by the movement of the white top plate, as shown on the right. And under this loading configuration, we get this response, which is ratcheting along the direction of mean load, even though we are cycling the perpendicular direction. And if we focus on the rotation accumulated due to this loading and compare that to an equivalent unidirectional loading configuration, we see that there's a drastic increase in the rotations accumulated, up to 160%. This means that this 90-degree wind-wave misalignment drastically reduces the performance of our foundation and needs to be considered during the design. We also looked at different loading configurations, as shown here, and we did a similar analysis. And if you want to know more about that, you can talk to me after. And the point of this whole experimental campaign was to use the results to validate a numerical model that can be used to predict the response to many other loading configurations, because at the end of the day, the offshore environment is multidirectional, and our model should be as well. Thank you.